Next, we are going to talk about applications in Google Cloud Platform, and we'll see this. How do you execute? Maybe tomorrow I'll give a demo. You can do hands-on on that. Okay, so here you have when you say application in the cloud, we're going to talk about your App Engine. So App Engine is a platform for building scalable App Engine is a platform for building scalable web application and mobile backends. It allows you to concentrate on innovating your application by managing the application infrastructure for you. For example, App Engine manages the hardware and networking infrastructure required to run your code. So App Engine provides you with a built-in service and APIs such as NoSQL, data store, mem store, load balancing, health checks, application logging, and user authentication API common to most applications. So App Engine will scale your application automatically in response to the amount of traffic it receives. So you can only pay for the resource you use. Just upload your code and Google will manage your app's availability. There is no server for you to provide or maintain. Security scanner automatically scans and detects common web application vulnerabilities. It manages early threats, identification, and delivery very low false positive rates. You can easily set up, run schedule, and manage security scans from the cloud console. App Engine works with the popular development tools such as Eclipse, IntelliJ, Maven, Git, Jenkins, and PyCharm. You can build your apps with the tools you love without changing your workflow. So that is what we are going to learn about App Engine standard environment. App Engine standard environment is based on container instance running in Google infrastructure. Containers are pre-configured with one of the service available runtimes. Each runtime also include library that supports App Engine standard APIs. For many applications, the standard environment, runtime, and libraries may be all you need. The App Engine standard environment makes it easy to build and deploy an application that runs reliable, even under heavy load with a large amount of data. It includes the following features: persistent storage with queries, storing and transaction, automatic scaling and load balancing, asynchronous task queues for performing work outside the scope of the request, scheduled tasks for triggering events at specific times or regular intervals, integration with other Google Cloud services and APIs. App Engine standard environment requirement you have. So App Engine standard. You require a software development kit for App Engine are available in all supported languages. Each SDK includes all of the APIs and libraries available in App Engine. A simulated secure standard environment that emulates all of the App Engine service on your local computer. Deployment tools that allow you to upload your applications to the cloud and manage different versions of your applications. The SDK manages your application locally, and the Cloud Console manages your application in production. The Cloud Console uses a web-based interface to create a new application, configure your domain names, change which version of your application is live, examine access to error logs, and much more. Application run in a secure sandbox environment, allowing the App Engine standard environment to distribute requests across multiple servers and scaling servers to meet traffic demands. Your application runs within your own secure, reliable environment that is independent of the hardware operating system or physical location of the server. In the diagram, we see App Engine standard environment in practice. You will develop your application and run a test version of it locally using an App Engine SDK. Then when you are ready, you will use the SDK to deploy it. So App Engine application runs in a Google Cloud project, and App Engine automatically provisions server instance and scales and load balances them. Meanwhile, your application can make call to a variety of services using dedicated APIs. For example, NoSQL data store to make data persistent, caching of that data using memcache, searching, logging, user login, and ability to launch actions, not triggers, but the direct user requests like task queues and a task scheduler. So then we have task scheduler, that also is there. Then we have flex environment. Why we need a flex environment? If the restriction of an App Engine standard environment sandbox model don't work for you, but you still want to take advantage of benefits of App Engine like automatic scaling up and down, consider App Engine Flex environment. Instead of a sandbox, App Engine Flex environment lets you to specify the container your application runs in. Your application runs inside a Docker container on Google Compute Engine virtual machines. App Engine manages these Compute Engine machines for you. They are health checks, healed as necessary, and you get choice what geographical regions they run, and critical backward compatibility updates to their operating system are automatically applied. All this that you can just focus on your code. Microservices, authorization, SQL and NoSQL databases, traffic splitting, logging, search versioning, and security scanning, memcache, and CDNs, content delivery networks, are all supported natively. Okay. In addition, App Engine Flex environment allow you to customize your runtime and run the operating system of your virtual machine using Docker files. So this the flexible environment includes native support for Go, Java, Java 8, PHP 7 or PHP 5 or 7, Python 2.7 or 3.6, .NET, Node.js, Ruby. Developers can customize these runtimes or provide their own runtime, such as your Ruby or PHP. By supplying a custom Docker image and a Docker file from the open source community, the infrastructure customization, because VM instance in the flexible environment are Compute Engine virtual machines. You can use SSH to connect to every single VMs, and Docker container for debugging purpose and future customization. Performance, take advantage of a wide array of CPU and memory configuration. You can specify how much CPU and memory each instance of your application needs, and the flexible environment will provision the necessary infrastructure for you. App Engine manages your virtual machine, ensures that instances are health checked, healed as necessary, and co-located with other module instance within the project. Critical backward compatibility updates are automatically applied to the underlying operating system. VM instances are automatically loaded by geographical region according to the setting is in your project. Google's managed service ensures that all of the project's VM instances are co-located for optimal performance. Okay. So VM instances are restarted as a weekly basis. During restart, Google managed services will apply any necessary operating system and security updates. So App Engine flexible environment apps that use standard environment can access App Engine service, data store, memcache, task queues, logging, users, and so on. What we have. Okay, here is a side-by-side comparison of a standard and flex environment. Notice that the standard environment startups instance for your application faster, but you can get access to the infrastructure in which your application runs. For example, the flexible environment lets you SSH into the virtual machine on which your application runs. and it also lets you to use local disk for scratch space. It lets you install third-party software. It lets your application to make calls to the network without going through App Engine. On the other hand, the standard environment build can drop to 0 for a completely idle applications. So deploying applications, GKE versus your App Engine, because we mentioned App Engine uses Docker. If you see here, if the App Engine uses Docker container, you may be wondering how App Engine compares with Kubernetes Engine. Here is a side-by-side comparison of an App Engine. With Kubernetes Engine, App Engine standard environment is for people who want service to take maximum control of their application deployment and scaling. Kubernetes Engine gives the application owner a full flexibility of Kubernetes. App Engine Flexible Edition is in between both of things. Also, App Engine environment treats a container as a means to an end, but Kubernetes Engine containers are the fundamental organizing principle. Okay. So we have one application. I'll show you a demo both the things like App Engine, Cloud Run, and your Cloud Functions tomorrow. Just the theory part I'm going to talk about today. So here also one more thing is that's a Cloud Endpoints and an App Engine. So let's be precise about the Application Program Interface or APIs. Okay, API is a software service implementation can be a complex and changeable. Yes, a software service implementation can be complex and changeable. If other software service has to be explicitly coded all that details in order to use that service, the result would be brittle and error prone. So instead, application developers structure the software they write so that is present a clean, well-defined infrastructure that abstract away needless details, and they document the interface. That's an application programming interface. The underlying implementation can change as long as the interface doesn't, and the other pieces of the software that use the API don't have to know or care. Sometimes you can have to change an API, such as to add or deprecate a feature. To make this kind of API change cleanly, developers version their APIs. Version 2 of the API might contain calls from the version 1 does not. Programs that consume the API can specify the API version that wants to use their calls. Supporting an API is a very important task, and Google Cloud provides the two API management tools. They approach related problems in a different way, and each has a particular forte, what we want to discuss now. So, Cloud Endpoint is a distributed API management system. It provides an API console, hosting, logging, monitoring, and other features to help you to create, share, maintain, and secure your API. You can use Cloud Endpoints with any APIs that supports the Open API specification, formerly known as the Swagger specification. Cloud Endpoint uses the distributed extensible service proxy to provide low latency and high performance for serving even the most demanding APIs. Extensible service proxy is a service proxy based on Nginx. It runs its own Docker container for better isolation and scalability. The proxy is containerized and distributed in a container register Docker registry, and can be used in App Engine, Kubernetes Engine, and Compute Engine and Kubernetes. Cloud Endpoint features. When we talk, okay, use authentication, use authentication, JSON, web token validation, and streamline developer experience for Firebase Auth, Google Auth, and Auth0. Automated deployment. With the App Engine, the proxy is deployed automatically with your application. On Kubernetes Engine or a Compute Engine, use Google Containerized ESP to simple deployment logging and monitoring. monitor traffic, error rates and latency, and review logs in Google logging. Use CloudTrace to dive into performance and BigQuery for analysis. So we have API keys. Generate API keys in a Cloud Console and validate every API call. Share your API with other developers to allow them to generate their own keys, and also provides easy integration. So to get quickly by using one Google Cloud Endpoint framework by simply adding Open API specification to the development. So Cloud Endpoint support applications. Running in Google Cloud Compute Platform in your choice of a language and your choice of a client technology. So you can see in the slide, language can be and the choice of a client technology. Then Apogee is one more. Apogee Edge is also a platform for developing and managing your API proxy. It has a different orientation though. It has a focus on business problems like rate limiting, quotas, analytical. Many users of Apogee Edge are providing a software service to other companies, and those features can be handy because the backend services for Apogee need not be in a Google Cloud. Engineers also often use it when they work to take a legacy application apart. Instead of replacing a monolithic application in one risky move, they can instead use Apogee Edge and peel off its services one by one, standing up microservices to implement each in turn until the legacy application can finally be retired. So practically, I will show App Engine, I'll show Cloud Functions, and so Cloud Run. Okay, we'll talk about last topic then, Cloud Run. Okay, Cloud Run is a managed compute platform that enables you to run stateless containers via web request or pub/sub events. Cloud Run is serverless. It abstracts away all infrastructure management so you can focus on developing applications. Okay, it is built on Knative, an open source Kubernetes based platform. It builds, deploys and manages modern serverless workloads. Cloud Run gives you the choice of running your container either fully managed or in your own GKE cluster. Cloud Run automatically scales up and down from zero depending on traffic almost instantaneously, so you never have to worry about scale configuration. Cloud Run also charges you only for the resource you use, calculate down to the nearest 100 millisecond, so you will never have to pay for your over provisioned resources. With Cloud Run, you can deploy your stateless containers with a consistent developer experience to a fully managed environment to your own GKE cluster. This common experience is enabled by Knative, an open source API and runtime environment built on Kubernetes that gives you freedom to move your workload across different environments and platforms. It's a fully managed on Google Cloud or on GKE, on anywhere the Knative runs. You can use a Cloud Run. Cloud Run is also a container based. Your Kubernetes is also container based. So Cloud Run you use when you don't want to manage any cluster, just deploy the Knative based containers. It also helps you to automate orchestration and so on.